Hello everyone. So today's video is about the equilibrium problems for statics, and we're gonna go for small basics first, and then we can solve one of the examples. And in the future, we're gonna make more videos about how to solve different problems about the equilibrium equation, any equilibrium problems. Okay. So anytime you see any problem that is equilibrium, that means like the object or the beam is not moving, you start to think about three important equations that if it's not moving, there is no the forces in the x directions is equal to zero, forces in the y direction equal to zero, and the summation of the moment is also equal to zero because it's not moving, it's not rotating, it's not like is it in a stationary movement. So these three equations should help us a lot to solve any problem, any equilibrium problem. Okay, let's go for this example, and we're gonna be highlighting the most important parts on it. So the beam in this figure supports 100 kilonewton, which is this one, uh, force and 600 kilonewton meter, which is there's a moment here. Couple determine the reaction at the fixed support A. Here we see it fixed support. From the last video that we made, we look at any supports and the reactions, and that was one of them, the fixed support. That's one of really most important ones. And to get the reactions is we're gonna have the reaction in the x direction, we have a reaction in the y direction, and we have a moment, which is ma. So if we go back here, let's simplify this one. Let's make it a free body diagram. Let's draw the free body diagram for this problem. Oops. There we go. So we say here is gonna be an reaction, let's say ax and ay, and we have here ma, and the change 600 kilonewton per meter. Okay, so coming in this force, we need to make it in the x direction and the y direction. So basically that will be 100 cosine theta, which is cosine 60, and up it's gonna be 100 sine theta, which is 60. Okay, and now we have all what we need to solve this problem. All the forces, everything now is right here. So that's 4 meters. Let's start with the summation of x. So summation of forces in x equal to 0. So what is the forces that we have on the x direction? So we have this one, and we have this one, right? So basically, we're gonna make ax, both of them in the same direction, both of them in the right. So the bosses should be has the same sign, which is, let's make it positive at that point. So ax plus 100 cosine 60 equal to 0. So that means ax equal 100 cosine 60, which is, if we use our calculator, we're gonna get that ax. Oh, I did a mistake. This should be, when it go here, is gonna be the negative sign. Be careful about that. There was a small mistake that now I just noticed it, and we're gonna get, if we use the calculator, it would be negative 50 kilonewton. Okay, so let's get the summation of y, f of y equal to 0. Same thing, both of them in the same direction. So ay plus 100 sine 60 equal to 0. Now we know ay equal negative because it's going to be the same thing. Sign is going to be changed. And the ay, if we use the calculator, would be 86.6 kilonewton. Last thing, we know that summation of the moment equal to 0. And let's make it summation of ma. So we pick up the point here. Why we pick up the point here? So we will not be worried about the ax and ay. So when you pick up the point, any force at that point will be cancelled out. You don't need it. You're only gonna be worried about the forces in the other directions, in the other locations. So when you move this one, when you choose the MA to be equal to 0, that means you're not worried about AX and you're not worried about AY. Okay? So we have MA, which is anti-clockwise. That means it's positive, MA. And we have here the moment, the 600 kilonewton the meter is clockwise, which is going to be negative 600. Okay, so 100 cosine 60, this one, we will not also worry about it because both of them, so basically it kinds of like multiplied by 0 because the distance, they're both at the same line, the same x direction. Okay, so that's also will not be worried about it because it's kind of like 0 multiplied by 0. The one that we're going to worry about is the 100 sine 60. So basically, to get the moment on this force, you're gonna make this one moving for this direction because this going up. So we kind of like you see the distance to go from here to here. So that is anti-clockwise. So that's positive 100 sine 60, and you multiply it by the distance. You see kilonewton dot meter. So we need to multiply by the meter, like the distance, which is 4. Okay, and that's all equal to 0. So we only have one unknown, which is also going to help us. MA equal 600 minus 4 divided by 100 sine 60. So MA will be equal to 154 kilonewton per meter. All right. As I mentioned, summation of f of x equals 0, summation of f of y equal to 0. The summation of the moment on the A point is equal to 0, and that's how we get all the force in A and the force of the AX and force in AY and the moment in the A point. All right, that's it for today, and